Okay, so if you just look at the slides, you can see Objective 2 is all about Scrabble, my wife's favorite game. I could care less about it. Anyway, so we're solving radical equations. And the way that you solve radical equations, so if I have square roots in them, so I want to square both sides, stuff like that. And so that's where this actual picture is very, very clever, because it says radical. Not only that, but each one of those is in the shape of a square.
Hi.
Hi. You gonna go take a nap?
Not yet.
Not yet. Okay. So, what's in your cheeks? What are in your cheeks?
Berries.
Berries? Delicious.
You're
Okay.
too fast for me. Come on now.
Go to bed. Hey, go take your nap.
Hey, a white one and a green one and a blue one.
Very good. You know your colors. Okay, so all of these are examples of radical equations. So radical equations just are equations that have radicals in them. Square roots, cube roots, whatever. You can have any index that you want to. So what I was just saying before Rowan came in here is that what I would be doing is I'd be squaring both of these sides so I can get rid of the square roots. And that's exactly what this is saying right here on the next slide. To solve these awesome equations, you raise both sides, you isolate the radical, and you raise both sides to a power so that all of your radicals mathematically disappear.
Dun, dun, dun.
So let's try that on this one. Okay, so I have to first isolate this radical. So I have a cube root of x in the equation. So I'll subtract the 10 over. So I'd have the cube root of x is equal to 27. And then, well, what's the inverse of cube rooting? It is cubing. So let's just cube both sides. The left-hand side, cube root and a cube will cancel each other out, leaving me with x because they're inverses. And 27 cubed is a really big number, so I'm going to leave it like that, 27 cubed. It does say check your answer. Well, if I leave it like that, that should be pretty simple here. So I'd have the cube root of 27 cubed plus 10. So the cube root and the cube would cancel out, and I'd get 27 plus 10 is equal to 37. Check. So here are the steps involved solving radical equations. I think you'll like this animation. So the first one, step number one, is to isolate that radical. Get it all by itself. Sometimes you have to get other stuff to the right-hand side of the equation. Step number two, you're going to raise each side to some power. It depends on what kind of radicals you have. If you have square roots, you're going to square both sides. If you have cube roots, you're going to cube both sides, and so on. And then finally, step number three, just solve the resulting polynomial equation. Sometimes it's linear, sometimes it'll be quadratic, and you guys can solve those, I think, right? All right, let's solve this one and check the solution again. Okay, so did I want you to do this? Yeah, why don't you try to do this on your own? And then pause it and come back and see if you did it correctly. Alright, I'm back from eating a couple more jelly beans. Anyway, what are we supposed to do here first? Supposed to square both sides. When you do, the radical on the left-hand side cancels out. And you have to square up the 11 over there. And when you solve, you get 26. Go back, stick back in, make sure it works. This one does. You're going to see why in just a second. I'll make it a big deal about checking your answers. Alright, so let's try this next one here. So it's a cube root. Oh my gosh, what are we going to do? Alright, so first divide both sides by 2. So I have a cube root of x minus 4. No, I don't. X minus 3 is equal to, so 4 divided by 2 is 2. Okay, I'm taking the cube root, so the inverse of that is cubing. Left-hand side, cube root and a cube cancel out, so I have x minus 3 is equal to, and then 2 cubed is 8. Add the 3 over x is equal to 11. Check it. So I have 2, ignore it, pretend it didn't happen, 2 cube root of, I'd have 11 minus 3. is equal to 2 times the cube root of 8, which is 2 times 2, which is 4. Yay. All right. So, wow, everything, I don't know why I'm checking them. I'm always getting them right. Let's try this next one. Okay, let's square both sides here. Get rid of that square root, square both sides. Left-hand side, it just cancels out, x minus 6. On the right-hand side, oh, man. I have a binomial I have to square. When I square that binomial, x squared minus, and then you multiply them together, and you double it, so 8 times 2 is 16x, and then plus the last number squared, 64. Alright, it's quadratic now. It was linear before, now it's quadratic. Get everything on one side of the equation. So 0 is equal to x squared. Let's subtract the x, that makes 17 of them, negative 17x. Add the 6, so that makes 70. So now I want to factor if I can. Let's see if I can. X, how about a 7 and a 10? Wow, that was easy. Minus and a minus. This means that x is equal to either 7 or 10. Let's check them, shall we? So let's check the 7. I'm gonna switch colors here. It's blue. So on the 7 here, I would have the square root of 7 minus 6. Square root of 7 minus 6 is just 1. Square root of 1 is 1. Is that equal to, on the left-hand side, I have 7 minus 8, which is negative 1? Oh, that doesn't work. What's that called again? Whenever you solve it and you get an answer that looks like it works, but it doesn't? That word. Okay, let's try the 10 then. I'm going to try 10 over here. So the square root of 10 minus 6 is the square root of 4, which is 2. And then over there, I'd have 10 minus 8, which is 2. Yay! That one does check out, so I do still get to have one solution. So that was an example of when it does pay off to check your answer, because sometimes you can get extraneous solutions. And so as you saw from that example, here it is summarized here. So basically, before you squared both sides, you would have stuck your number in and you would have gotten something like negative 1 equals 1. If you were to square both sides of that, negative 1 squared equals 1, 1 squared is equal to 1. Now that number that you originally stuck in there looks like it works, but it didn't work before you squared it, and that's why it's extraneous. All right, here's one for you to try on your own, because that one's kind of tricky. Maybe makes it a quadratic. Try it on your own. Come back, check, see if you did it right. What'd you get? Did you get this? So when you square both sides and you solve it, you do get quadratic, but the constant term drops out, so you're just left with, you can just pull out an x from that. You just GCF of x, and you get x times x minus 4. So the first one, 0. Second one, 4. Check them both out. I checked one of them in blue and one of them in green. They both worked out. Awesome. Okay. So we're going to, in the next video, look at some slightly more complicated ones.
Dun, dun, dun.
All right?